Hi guys, and welcome to our final form of a quadratic function, the vertex form. Alright, so just some new terminology. The parent function for all quadratic functions is y equals x squared and is graphed below. This just means that there are no transformations. Alright? So our vertex form of a quadratic function is going to be y equals a times x minus h squared plus k. Alright, and let me make that h a little bit more pronounced. Okie dokie. So this looks a little scary, but it's actually the easiest one of all of our forms because our axis of symmetry x equals h. So whatever this value is, that's what our x equals. But if you notice, inside the parentheses we have a negative. Therefore, h lies. Okay? So if this was a -3, then over here our axis of symmetry would be 3. And then our vertex is going to be h comma k. And you get your k from right there. Alrighty. Also, for our parent function, as always, domain is all real numbers. And just quickly, if you go from bottom to top, you reach that 0 and go to positive infinity. Alrighty. So, every graph of a quadratic function is a transformation of our parent function y equals x squared. So just everything is manipulated by this. Okay? So shifts and translations describe how to graph the vertex from the origin. That's the moving up and moving left and right. So H describes the horizontal shift, which is left and right. And K describes the vertical shift, which, of course, is up and down because it's vertical. Alright? So we've talked about this before. Shrink and stretch describes the change and the width of the parabola. So we haven't really discussed the width of the parabola, but we have discussed shrink and stretch. So if a is greater than 1, meaning if it's a whole number, then there is going to be a vertical stretch. Or it gets skinny or narrow. Okay? And if a is in between 0 and 1, meaning that it's a fraction, then there is a vertical compression. It gets wider. And vertical compression is another word for shrink. And reflection across the x-axis, which we've talked about. If a is less than 0, or negative, then it is reflected across the x-axis. Alrighty? So we're going to take a look at our first example. And we have y equals x plus 1 squared minus 3. Well, the first thing that I want you guys to do is I want you to list out what your a value is. Okay? So our a is 1. Because remember, it's going to be whatever number is in front of our parentheses. Okay? Our h, remember h lies, so that's going to be -1. And then our k, we can take directly from, is -3. Okay? Alright. So, when it says opens, it's asking if it is a max or a min. And so it opens up because it's a minimum. Alright? Our vertex is hk. And so that's going to be -1, -3. Shift Shift is another word for transformations. And so we are going to go down 1, whoops, sorry, no we're not, left 1, down 3. All right, shrink or stretch. So because A equals 1, we have neither. All right, is there a reflection across the x-axis? Well, our A is positive, so no. And then, because it opens up, we have a minimum at y equals -3. So at y equals k. There you go. All right, let's take a look at the next one. List out what your A is. A is -2. I'm right here. H is +3. Remember, H lies. And K is 5. There we go. All right, so does this open up or down? This one is going to open down because A is negative. Our vertex is going to be 3, 5, which means that we're going to the right 3 and down 5. Shrink or stretch. So A is a whole number, so this time we're going to have a stretch because A equals 2. Reflection, yes, because A is a negative. Max or min, this time we have a maximum at y equals 5. Alrighty, let's try the next one. So our A equals 1/2. Our H equals +4. And our K equals -5. Because remember, H lies. So this one opens up because A is positive. Our vertex is going to be 4, -5. Our shift is to the right 4 and left, whoops, sorry, down 5. Oops. Let's actually be able to see what I'm writing there. Down 5, not left. And then this time it's going to be shrink because A is a fraction. And there is no reflection across the x-axis because A is positive. And we have a minimum at y equals -5. Alrighty, good job guys. Alright, let's move on to the next page. Okay. Or at least the next side of our page. So for each of these, you need to graph it. Alright, well, we already have a lot of information given to us. For example, we can already determine our axis of symmetry, which is going to be our H value, which is going to be -1. And then we know our vertex is going to be -1, -3. Alright, so we can go ahead and graph our axis of symmetry and our vertex, -1, -3. And then all you have to do is make your x, y table of values with -1, -3 in the middle. Alright, and so this is where we would grab our handy dandy calculator and put it into our table of values. Okay? Alright, so here's our calculator. We press the table button We clear out whatever is there, and then we enter in our equation exactly as we see it. X plus 1 squared, and then minus 3. And then, as always, we start at our vertex, which is going to be negative 1. And then for 0, we have negative 2, which means that at negative 2, it's also going to be negative 2. And then at negative 3, it's 1, which means at 1, it's 1. Ta-da! Okay? And so now you can plot those points. So we have negative 3, 1. We have negative 2, negative 2. And then you can just connect your dots. Okay? Alright. So then let's try the next one. For number 5, we need to make sure that we have our XY table of values. And then our axis of symmetry is x equals 3. Because remember, h lies. And then we have our vertex is going to be 3, 5. Okay, and so now we know that we need to put our vertex 3, 5 here. And then we go 2, 1, 4, 5. And then using our table again, clear out that, clear out that. And we have negative 2, parentheses, x minus 3, squared, plus 5. Whoops. And remember, we need to start at our vertex. There we go. So 3, 5, so we did that part right. And then it says 4, 3, which means that at 2, it should also be 3. And then at 1, it says negative 3, which means that at 5, it should also be negative 3. Excellent. Alrighty. So then we can go ahead and graph those. And then just connect your dots. Alright, cool. Alright, I want you guys to try number 6. Alright, I believe you guys can do it. You try. Okie dokie. And in the meantime, so you should be pausing this video while the rest of us move on. Alrighty, so number 7 looks tricky, but I promise it's not terrible, because you just need to recognize that this is in vertex form. It just doesn't look like it. Okay? So let's try expanding it out. Alright, we have our y equals our a, and parentheses, x minus 0 squared plus k. Because then what is x minus 0? It's just going to be x. So then you would have 3 times x squared. Whoops, this is supposed to be minus 4, sorry. And then the square just goes with the x, which is how you get 3x squared minus 4. Okay, but this is the form that we want to work with because it's our vertex form. So what's our vertex? It's going to be 0, negative 4. Alright, and so this time we're just going to move down 4. And it is going to be a stretch because a equals 3. And there is no reflection because a is positive. And we do have a minimum at y equals negative 4. Sorry, I know I'm going through this kind of fast now, but we have done the transformations, the shrink and stretch and reflection and max and min for quite a while now. So you guys should know these. Alright. And then same with domain. You better know it. All real numbers. Okay. The only one that you may not be okay with is range, and so that's just when we have to make our table of values. Alright, so xy, and then make sure that your vertex is in the middle. And then just make sure that you put it into your table of values, okay? And so, in your table of values, and let's clear out that, clear, and then we have 3x squared minus 4, and we're going to start at 0, so then we get 1, negative 1, 2, 8, okay, and then we can go ahead and graph it. Alright, so 0, 4, negative 4, sorry. Alright, do you see how skinny this graph is? How narrow it is? That's what the stretch is. So as it gets skinnier and skinnier and skinnier, that's the stretch. When it goes fatter and fatter and fatter, that's the shrink. Okie dokie. Alright, and so then range, you go from bottom to top, and of course you hit your bottom of negative 4, and then you continue to go up to positive infinity. Alright, so I want you guys to try number 8. Let's see what you can do. Alright, and then on the back, same deal. Okay, so on the back we have our vertex of negative 1, positive 5, because remember that H lies. Oops. We have our transformations of left 1 and up 5. This time we have a shrink because A equals 1/2. We do have reflection because A is negative, which means that we also have a maximum at Y equals 5. Our domain is always going to be our real numbers. And then we need to graph in order, and we should be pretty good at graphing by now because we have to make our XY table of values. Alright, so XY, make sure your vertex is in the middle. Okay. Alright, so then table, and we're going to clear that. And then we have negative 1/2 x plus 1 squared plus 5. And then we have to start at negative 1. Okay, good, negative 1/5, so we did that right. Oh my gosh, look at that. There is a fraction. That's okay. That's just 4.5. We can work with 4.5. And then at 1, it's going to be 3. Okay. So at negative 1, we have 5. At 0, we have 4.5, which will be about right there. And same over here. And then at 1, we have 3. And at negative 3, we have 3. Boop. Boop. Okay. And so then, going from bottom to top, we hit negative infinity because we have arrows. And then we go all the way up to our vertex, which is going to be positive 5. Awesome. Alrighty. So now we're going to look at number 9, and we need to describe the transformations from the parent function to the new function. So what I want you to do is list out what your A is, which is going to be negative 3. List out your H, which is negative 5, and your K, which is negative 9. Okay? So it wants that we have a stretch of 3 because of our A. We move to the left 5 because of our H, and down 9 because of our K. And then there's one more. We have reflection because of our A is negative. Alrighty? Okay, so now for number 10, we want to write the function after it has been translated right 4 units and up 7. Okay, so remember our general form, y equals a times x minus h squared plus k, where this is going to be our h and this is our k. Alright, but remember, h lies. Okay, so it didn't tell us anything about our a value because it didn't say reflected or shrink or stretch, so I'm going to have y equals 1 and then x, and then this says right, so I'm going to make it a negative because it lies to me, squared, and then plus k, and it says up 7, and we just did it. And we're done. Okay? Let's try 11. Alright, so we're going to write it after it has been translated left 2 units and up 1. So y equals 1, x plus 2, because remember, h lies, squared, and then plus 1. Okay? Ooh, I like 12. 12 uses different vocab. Okay? Write the quadratic function with an axis of symmetry, aka an h value, and a minimum, which is our k value, of -6. Now notice it says minimum. Okay, this just means that a is positive. Okay, so we don't have to do anything. So we have y equals 1, x minus 3 squared minus 6. Alright, but what if it said maximum? If it says maximum, because we have an axis of symmetry, which is our h, and a maximum, which is going to be our k, but now a is negative. Okay, so now I need y equals -1, x plus 5 squared plus 2. Okay? Alright, so then I want you to try 14. And then we won't do 15. Okay. Alright, so I want you to do 14 and then you'll be done with these notes. Good luck.